Tonight, we're traveling across a world that appears calm and welcoming, a planet wrapped in green and blue, familiar and alive. Yet beneath that peaceful surface, Earth carries a much older story, one it never fully let go of. Most people imagine ice ages as events buried deep in Earth's past, frozen chapters already closed. But the ice never truly left. For millions of years, Earth has moved back and forth between deep cold and brief warmth. Ice has guided oceans, winds, migration routes, and the slow evolution of life. Geological time does not hurry. Climate states settle in and linger, lasting far longer than any civilization ever could. What feels normal to us may simply be a pause the planet allows. Today's world looks gentle on the surface, forests growing and cities spreading beneath open skies. But beneath that appearance, the deeper systems of Earth still behave like a frozen planet. So, why do scientists believe that we are technically still in an ice age? How does permanent ice quietly guide the planet's long term behavior? And is the world we know the rule or the exception? Tonight, we gently explore the calm surface of a planet resting between deeper extremes. But before we begin, I'd love to know, where in the world are you listening from tonight, and what time is it there? And if these late night explorations help you unwind, a like and a subscribe would mean a lot. So now take a deep breath, let your shoulders loosen, and together let us drift softly into the lingering presence of ice that still shapes our world. The way scientists understand Earth's climate is shaped by patience rather than urgency, by a willingness to watch patterns unfold across spans of time so vast they soften the meaning of change itself. Instead of focusing on years or even centuries, they step back until decades blur into thin lines and entire civilizations fade into brief flickers against a deeper backdrop. Climate, in this view, is not a mood or a season, but a long posture the planet holds while everything else passes through. To see this posture clearly, scientists rely on signals that endure: ice carved into mountains, sediments layered at the bottom of oceans, tiny chemical fingerprints locked inside ancient shells, or frozen air. These records do not speak loudly or quickly. They accumulate slowly, grain by grain, layer by layer, preserving the quiet memory of what persisted long after surface conditions shifted. What matters most is not how warm a moment became, but whether the planet ever fully let go of its cold. Permanent ice changes everything. Once ice remains year round at the poles, Earth begins to behave differently, even during warm intervals. Light reflects more readily back into space, oceans circulate in altered paths, winds settle into long standing patterns. These effects do not vanish when temperatures rise for a time. They linger, shaping the planet from beneath the surface, guiding climate the way deep currents guide the sea. For scientists, this persistence carries more weight than any short lived spike in warmth or cold. Warm phases still matter, but they are understood as chapters rather than entire stories. They arrive, settle briefly, then ease away again, leaving the deeper structure untouched. A few thousand years of calmer conditions can feel enormous when measured against a human lifetime, yet in geological time they resemble a held breath. The long climate state is defined by what remains unchanged, while these warmer moments come and go, like sunlight drifting across an ancient stone wall that never moves. This is where human intuition falters. Minds shaped by daily weather and seasonal rhythms instinctively treat recent experience as normal, as a baseline from which all judgment flows. A stable climate lasting many generations feels permanent, even inevitable. Geological records quietly contradict this instinct, revealing that what feels enduring to us is often brief when placed against millions of years. The planet does not mark its eras according to comfort or familiarity, but according to structures that refuse to disappear. Scientists learn to translate between these scales by letting go of urgency. They resist the pull of the immediate, choosing instead to listen for slower signals that only emerge with distance. A layer of ice surviving through repeated warm intervals speaks more clearly than a single rise in global temperature. It tells a story of thresholds crossed and not uncrossed, of systems that have settled into a particular rhythm and continue to follow it even when surface conditions appear to soften. Climate eras, then, are not defined by how the world feels at any given moment. They are defined by what the planet can no longer escape. Permanent ice marks a boundary, a line after which Earth's behavior remains anchored, even as conditions above it drift and change. Understanding this requires stepping out of human time and into planetary time, where stability looks unfamiliar and change moves at a pace so slow it can seem almost still, carrying the quiet certainty of something far older than experience. What most people picture when they hear the phrase Ice Age is a world locked in white, continents buried, oceans frozen at the edges. That image lingers because it feels dramatic and complete, as if cold must dominate everything to matter. Yet the planet's deeper story moves more quietly than that. Ice ages are not announced by spectacle, but by persistence, by what remains long after warmth returns to the surface. In the long language of geology, ice ages are not defined by how far ice spreads, but by whether it ever truly leaves. The difference is subtle, yet profound. A planet can warm, forests can expand, seas can soften at their margins, while ice continues to endure at the poles. That endurance becomes the marker. As long as ice survives somewhere year after year, the planet remains in an ice age, regardless of how gentle the climate may feel elsewhere. This presence reshapes Earth in ways that do not fade with seasonal thaw. Polar ice acts as a steady anchor, locking sunlight into reflection rather than absorption, guiding winds into familiar paths, encouraging oceans to move heat along deep and deliberate routes. These influences do not require ice to dominate the land. They require only that it persists, quietly reinforcing the same planetary behaviors over immense spans of time. Once ice establishes itself at the poles, the planet does not return to its earlier balance easily. Even during long warm stretches, the climate carries the imprint of that frozen foundation. Warmth becomes layered on top rather than replacing what lies beneath. Ice retreats and advances, but the overall system remains shaped by its continued existence. This is why scientists see ice ages not as periods of constant cold, but as regimes, long lasting states that include both frozen depths and warmer interludes. The persistence of polar ice signals a shift in how Earth responds to change. Before ice took hold, warmth could spread freely from equator to pole, smoothing contrasts and softening extremes. With ice present, that flow is altered. Heat meets resistance, light is redirected, feedbacks settle into place. The planet becomes more sensitive to small variations, more prone to cycling between cold and warmth without ever fully escaping either. This single detail, the survival of ice somewhere on the globe, reshapes the entire definition of climate eras. It explains why worlds that look familiar on the surface can belong to fundamentally different categories beneath. Two periods may share similar temperatures and ecosystems, yet belong to different climate states because one still holds ice, and the other does not. The distinction lies not in appearance, but in structure. Human intuition struggles here because it is trained on visibility. We judge by landscapes we can see, by weather we can feel, by stories that unfold within a lifetime. Ice ages operate on rules that ignore those scales. They are defined by thresholds crossed once and rarely reversed, by conditions that persist quietly while everything else seems to change. Understanding this reframes the planet's recent past and its present posture. Warmth no longer reads as an ending, nor cold as a beginning. Both exist within a larger rhythm governed by what the planet refuses to relinquish. As long as ice remains, Earth continues to behave according to the logic of an ice age, carrying forward a state that endures beneath shifting skies, steady and patient, shaping the world in ways that unfold too slowly to notice, yet too powerfully to ignore. For much of its long existence, Earth did not carry ice at its poles. The planet spent vast stretches of time in states where frozen water never settled into permanence, where warmth reached unbroken from equator to high latitudes. These periods did not feel transitional or unstable. They were complete worlds, sustained for millions of years, operating under rules very different from the ones that quietly shape the present. In those ancient climates, the absence of ice allowed heat to move freely across the globe. Oceans carried warmth without interruption, winds traced gentler paths, and seasonal contrasts softened across continents. Forests and seas extended farther toward the poles, blurring the boundaries that now divide tropical from temperate, temperate from polar. The planet's surface held a coherence that no longer exists, a smoothness created by the uninterrupted flow of energy. Without permanent ice, Earth responded to change more slowly. Temperature shifts unfolded gradually, buffered by oceans and atmosphere working in unison rather than opposition. Feedbacks that now amplify cooling or warming remained dormant. Light was absorbed rather than reflected, reinforcing stability instead of promoting cycles. The planet, in these times, behaved like a single connected system rather than a collection of regions locked into contrast. These ice free worlds were not merely warmer versions of today, they were fundamentally different in structure. Sea levels rested higher, reshaping coastlines into unfamiliar outlines. Chemical cycles moved at different rhythms, influencing how carbon traveled between air, water, and rock. Life adapted to wide, continuous habitats rather than fragmented zones. Evolution unfolded on landscapes without the repeated pressure of advancing and retreating ice. The rarity of such conditions becomes clear when seen across Earth's full timeline. Ice-free states required precise balances, sustained greenhouse gases, stable continental arrangements, and uninterrupted circulation patterns. Small disruptions could tip the planet away from this equilibrium. Once ice finally gained a foothold, even briefly, the system began to change its behavior. Reflection replaced absorption, sensitivity replaced inertia, and cycles emerged where steadiness once prevailed. After ice established itself, returning to an ice-free world became increasingly difficult. The planet's climate acquired memory. Each period of cold reinforced the conditions that favored its return. Feedbacks stacked quietly, making the absence of ice not only uncommon but increasingly fragile. What had once been Earth's norm transformed into an exception, appearing only under rare alignments of conditions that were hard to sustain. Seen through this lens, warmth loses its familiarity. The present arrangement, with ice lingering at the poles and warmth spreading unevenly elsewhere, represents neither the planet's youth nor its middle age, but a later chapter shaped by thresholds already crossed. Earth no longer drifts freely between states. It oscillates within boundaries defined by what it can no longer erase. Understanding this deep history places the modern world into a broader context. The greenery, the oceans, the gentle climates that feel natural today exist atop a framework built by cold, beneath familiar skies. lies a system tuned by ice, shaped by its persistence, and constrained by its presence. Ice free Earths belong to a quieter, older story, one that unfolded slowly and completely before the planet adopted the rhythms that now define it. In the long memory preserved within stone and sediment, warmth appears less as a default and more as a condition earned and often fleeting. The planet's history does not lean naturally towards softness. It remembers stability without ice as something rare, delicate, and distant, while the influence of cold continues to guide Earth's behavior, steady and unyielding, beneath a surface that can appear endlessly alive. The shift did not arrive with thunder or sudden silence. There was no instant when the planet appeared changed. Ice had already been visiting the poles for ages, advancing and retreating with slow familiarity, responding to subtle changes in sunlight and circulation. What altered everything was quieter than any visible event. At some point, the ice stopped leaving entirely. Season after season, warmth returned, oceans breathed out heat, and yet a residue of ice remained. Summers softened its edges, but did not erase it. Winters rebuilt what little was lost. Year by year, that balance leaned ever so slightly toward permanence. The poles began to remember the cold. What had once been a visitor became a resident, lingering through cycles that once would have sent it away. This was the moment Earth crossed a threshold that cannot be seen from the surface. Ice no longer behaved as a temporary feature, but as a structural one. Its continued presence altered how sunlight interacted with the planet, how winds carried energy, how oceans stored and released heat. These changes were not abrupt. They accumulated gently, reinforcing one another so gradually that no single generation could have noticed the difference. As ice endured, Earth's climate slipped into a new long-term mode without ceremony. The planet began operating under a different set of rules, even though the landscapes above appeared much the same. Forests still grew, seas still rolled, life continued its long unfolding. The machinery beneath these familiar scenes, however, had shifted. Ice had become part of the system's foundation rather than an overlay that could be wiped away. This transition did not announce itself because it unfolded across stretches of time that defy intuition. Thousands of years passed without obvious disruption. Warm periods still arrived, bringing green back to high latitudes, softening winds, calming seas. Yet beneath each warm interval, ice endured in shadowed basins and polar reaches, quietly anchoring the climate to its new state. The planet did not cool all at once. Instead, it became more responsive. Small changes began to matter more than they once had. Slight shifts in orbit or atmospheric composition produced outsized effects compared to earlier eras. The climate gained sensitivity, its rhythms tightening, its swings becoming more pronounced. Ice was no longer simply reacting to change, it was shaping the response itself. For those who lived within this transition, nothing would have felt final. There were no collapsing ecosystems or global upheavals tied to this threshold. The world did not appear broken or unstable. It simply carried on, unaware that a door had quietly closed behind it. Earth had entered a state from which it would not easily return. What makes this moment difficult to grasp is its subtlety. The idea of no return suggests drama, yet the reality was closer to habit taking hold. Ice staying a little longer each cycle, warmth failing to fully reclaim what it once erased. Over immense spans of time, these small imbalances accumulated into permanence. From that point forward, Earth's climate carried memory. Each cold phase reinforced the next. Each warm phase arrived already constrained. The planet learned a new pattern and began repeating it, not through force, but through persistence. The point of no return was not a line crossed in an instant, but a direction chosen so gradually that it felt like nothing at all. By the time the shift became clear in the deep records of stone and ice, it was long complete. Earth had settled into a colder posture, not harsh or hostile, but structured around the quiet certainty that ice would remain. And from that moment onward, every future climate would unfold within the boundaries set by that enduring presence, steady and unspoken, shaping the planet without ever needing to announce itself. Once ice became part of Earth's enduring structure, it began to influence the planet in ways that extended far beyond its physical boundaries. Ice does not need to spread dramatically to exert its power. Its presence alone alters how Earth handles energy, quietly shifting balances that shape the entire climate system. The cold does not advance by force, but by reinforcement. Ice reflects sunlight. Where darker land or open water would absorb warmth, ice sends much of that energy back into space. This reflection cools the air above it, which in turn protects the ice below from melting. Even a modest patch of persistent ice can lower regional temperatures, encouraging nearby snow to last longer, oceans to remain cooler, and winds to adjust their paths. The effect is subtle at first, but steady. As cooling deepens, the conditions that favor ice quietly expand. Snow falls more readily on cooler surfaces and lingers longer before melting. Seas near icy margins release less heat into the atmosphere. Glaciers grow heavier and more resistant to seasonal change. Each of these shifts reinforces the next, creating a loop that does not rely on dramatic drops in temperature, only on consistency. This feedback operates patiently. Ice does not need to conquer new ground quickly, it simply needs to survive. With each cycle it remains, it encourages the planet to behave in ways that favor its continued existence. The climate grows accustomed to its presence, reorganizing circulation patterns and energy flows around it. Over time, ice becomes part of the baseline rather than an anomaly. The oceans play their part as well. Cold water near ice sinks more readily, drawing warmer water toward the poles at depth. This circulation redistributes heat in specific ways, often delivering warmth beneath the surface while leaving the upper layers cool. The ice above remains insulated, protected by water that moves heat elsewhere. The system becomes efficient at preserving frozen regions, even during intervals of relative warmth. This self-sustaining quality explains why ice, once established, is difficult to erase completely. Melting requires more than temporary warmth. It demands prolonged conditions strong enough to overwhelm multiple reinforcing processes at once. Without that sustained push, ice retreats only partially before reclaiming its ground. What appears like loss at the surface often conceals survival beneath. Through this process, ice transforms from a response into an influence. Instead of simply reacting to climate, it begins shaping it. The planet's sensitivity increases, its rhythms tighten, and its swings become more regular. Warm periods still arrive, yet they do so within boundaries defined by ice that refuses to vanish. The result is a planet that remembers its cold. Each surviving glacier, each polar sheet, acts like a quiet anchor, holding Earth within a particular range of behavior. Even when warmth spreads across continents, the underlying system remains tuned toward ice retention. The climate becomes less free to drift, more inclined to return. Over immense stretches of time, this persistence accumulates power. Ice does not need intention or momentum. It relies on balance, reflection, and habit. Once the planet learns how to keep ice, it keeps doing so. The cold reinforces itself through countless small interactions that require no awareness and leave few immediate signs. This is why the appearance of permanent ice marks such a profound shift in Earth's story. Not because ice dominates everything it touches, but because it teaches the planet a new way to behave. From that point onward, ice becomes less a guest and more a resident, quietly shaping climate through its continued presence, steady and unassuming, guiding Earth toward patterns that endure long after any single warm moment fades away. Long after ice became a permanent companion to the poles, the planet settled into a deeper rhythm that unfolded with steady patience. This rhythm was not driven by weather or surface change, but by slow motions written into Earth's path through space. The planet's orbit and its gentle tilt shifted over time, almost imperceptibly, altering how sunlight arrived across latitudes and seasons. These motions repeated with calm regularity, forming a clock that never hurried and never stopped. Each turn of this clock adjusted the balance of light and shadow in subtle ways. Sometimes summers grew slightly milder, allowing snow to persist a little longer. Sometimes winters softened just enough to let ice pause its advance. The changes were small, far too small to notice within a lifetime. Yet the climate responded faithfully because ice had already taught the planet how to amplify faint signals. When sunlight weakened at high latitudes, ice endured more easily. When it endured, it reflected more light, reinforcing the original change. Oceans adjusted their circulation, storing and releasing heat along altered routes. Winds followed these shifts, carrying cold or warmth with gentle persistence. What began as a minor adjustment in Earth's position became a wide response across the climate system, unfolding without drama, yet carrying immense consequence. These cycles did not create ice ages on their own. Instead, they shaped how ice behaved once it existed. The planet no longer drifted freely between extremes. It responded to the same repeating signals again and again, deepening patterns already in place. Cold phases lengthened, warm phases softened, and the boundaries between them became familiar. Earth learned the cadence of its own motion and adapted itself accordingly. As the cycles continued, they etched long rhythms into the planet's history. Ice advanced during certain alignments, retreated during others, and always returned when the clock's slow hand came back around. The timing varied, but the pattern endured. Over many cycles, this repetition reinforced stability of a particular kind, one defined not by constant conditions, but by reliable return. To a surface observer, these shifts would have seemed gradual, almost uneventful. Landscapes changed slowly, ecosystems adapted, coastlines adjusted by degrees. Yet beneath this calm progression, the clock kept turning, guiding climate through corridors shaped long ago. Each phase followed the previous one not because it was forced, but because the system had learned to respond that way. The power of this hidden clock lies in its predictability. Once ice existed and feedbacks were established, the planet became synchronized to orbital rhythm. Small variations no longer passed unnoticed. They resonated through a system already tuned to respond. Climate swings grew larger than their initial cause, not through instability, but through faithful repetition. Over immense spans of time, these cycles locked Earth into a familiar pattern. Warmth arrived, lingered, and eased away. Cold followed, advanced, and settled. Neither state dominated completely, yet neither could be escaped. The planet moved like a pendulum whose arc was determined by deep structure rather than surface force. This rhythm did not rush toward resolution. It carried on with even pace, shaping ice, oceans, and life itself. Migration paths shifted, habitats expanded and contracted, and evolution learned to move with the beat rather than resist it. The climate clock did not dictate detail, but it defined boundaries within which all detail unfolded. By listening to this slow music of motion, scientists uncovered a sense of order beneath apparent variability. What seems unpredictable in short spans resolves into pattern when time stretches wide enough. Earth's climate, guided by its quiet clock, continues to follow these long rhythms, steady and enduring as it has since ice learned to remain. By the time the first humans began to take shape, the planet was already living inside a restless climate. Ice expanded and retreated with slow insistence, reshaping landscapes over spans longer than memory yet short enough to matter. Valleys deepened under glaciers, plains opened where seas once stood, and familiar routes shifted again and again. Humanity did not emerge into a stable world. It emerged into motion. Early human populations learned this instability as background rather than threat. Cold periods pressed outward from the poles, narrowing forests and drying grasslands, then eased back, allowing life to return along altered paths. Rivers changed course, coastlines advanced and withdrew, and animals moved in response. Humans followed, not once, but repeatedly, carried by necessity across expanding land bridges and newly exposed corridors. Migration became more than movement, it became a way of living. Groups learned to travel light, to read changing skies and shifting vegetation, to remember places that vanished, and to find new ones forming. The cold taught timing. It rewarded those who moved when conditions allowed and punished those who lingered too long in places that would not remain kind. This rhythm of departure and return etched flexibility into human behavior. Ice shaped tools as well. Scarcity demanded efficiency. Stone blades grew sharper, techniques more refined. Fire was guarded carefully, shared deliberately, and carried forward rather than rediscovered each time. Clothing, shelters, and social bonds strengthened under pressure. Survival favored those who could cooperate across seasons of uncertainty, who could adapt skills to unfamiliar terrain and shifting prey. Cold did not dominate every year, but its presence was constant enough to influence every generation. Even during warmer stretches, the memory of harshness remained embedded in culture and practice. Humans did not assume permanence. Camps were temporary, resources were diversified, and knowledge passed between generations carried lessons learned during colder times. The environment encouraged readiness rather than comfort. Adaptability emerged quietly as humanity's defining trait, not through strength alone, but through learning, imitation, and innovation. The mind became a tool as essential as any crafted object. Storytelling preserved roots and dangers, language refined cooperation, social structures widened, allowing groups to survive losses and benefit from shared experience. In a world that refused to settle, flexibility became security. The Ice Age context also shaped perception of time. Seasons mattered deeply, but so did longer cycles sensed rather than measured. Changes unfolded slowly enough to seem normal, yet frequently enough to demand attention. Humans became observers of gradual shifts, readers of subtle signs, attuned to patterns that repeated with variation. This awareness fostered anticipation rather than control. Within this shifting world, humanity did not conquer climate. It learned to live alongside it. The cold sculpted bodies and behaviors, encouraging endurance and awareness. Warmth offered reprieve, but never assurance. Each generation inherited a world slightly different from the one before, and this continuity of change became the constant. The Ice Age into which humans were born did not define them through hardship alone. It offered pathways, opportunities, and challenges that rewarded ingenuity. Movement opened new lands. Change fostered creativity. Uncertainty nurtured cooperation. Over time, these qualities accumulated, not as deliberate choices, but as traits quietly selected by circumstance. Humanity's greatest strength was not resistance to cold, but responsiveness to change. In a climate that never stood still, adaptability proved more durable than any single strategy. That lesson, learned slowly across icy plains and retreating glaciers, became embedded in what it meant to be human, shaping a species prepared not for one world, but for many. There came a time when the ice reached farther than it ever had before in human memory. It did not rush forward, but advanced patiently, century after century, until vast sheets of frozen water pressed deep into continents. Mountains disappeared beneath white weight. Valleys filled, hardened, and fell silent. The world narrowed as cold claimed space that once held forests, rivers, and open ground. At this peak, ice reshaped the planet's surface into something unfamiliar. Sea levels sank as enormous volumes of water were locked away in frozen form. Coastlines crept outward, revealing wide shelves of bare land where waves had once broken. Islands merged with mainlands. Shallow seas became plains swept by cold winds. The map of Earth changed quietly, creating temporary bridges and broad corridors that existed only because the oceans had retreated. These exposed lands were harsh and open. Grasses and low plants clung to thin soils. Dust traveled great distances, carried by persistent winds blowing off ice fields. The air itself felt different, drier and heavier with cold. Seasonal rhythms stretched and tightened in unfamiliar ways, with long winters and brief, fragile summers that never fully softened the land. For human populations, this world demanded constant movement and attention. Resources were sparse and unevenly distributed. Herd animals followed narrow paths between surviving pastures, and humans followed with them. Camps shifted frequently, tracing routes dictated by ice margins and seasonal openings. Knowledge of where food might appear mattered as much as strength or skill. Survival hovered close to its limits, not because life was always collapsing, but because there was little margin for error. Small misjudgments carried heavy consequences. A delayed migration, a failed hunt, or an unexpected shift in weather could mean loss that echoed through generations. Communities relied on collective memory, cooperation, and careful timing to endure within such tight boundaries. Fire became more than warmth. It was a center around which life organized itself. Tools were refined to conserve energy and maximize usefulness. Clothing and shelter evolved to protect against prolonged exposure rather than occasional cold. Social bonds deepened, reinforced by necessity. Shared effort reduced risk in a world where isolation could be fatal. Yet, even at its coldest, the planet was not lifeless. Life endured in pockets of resilience. Certain regions escaped the heaviest ice, offering refuges where plants, animals, and humans persisted. These places became anchors of continuity, preserving lineages and knowledge until conditions shifted again. The ice did not erase life, but it pressed it into narrower spaces. The closeness of survival during this time shaped human behavior in subtle ways. Adaptation favored patience and observation over dominance. Success depended on reading landscapes accurately and responding before change became catastrophe. Over time, this fostered a relationship with the environment based on attentiveness rather than control. When the ice sheets stood at their greatest extent, the world felt immense and constrained at the same time. Vast open spaces stretched between pockets of life, yet movement through them required precision. Earth's surface carried the marks of cold everywhere, from lowered seas to reshaped terrain, from altered winds to migrating ecosystems. This coldest chapter did not announce an end. It existed as a moment of maximum pressure within a longer rhythm. Humanity endured, not because conditions were forgiving, but because adaptability had already taken root. Survival remained possible, though always close, sustained by cooperation, learning, and the quiet persistence that had already carried humans through a world that refused to stay still. After the height of cold eased its grip, the world did not change abruptly. Ice withdrew slowly, not as a retreat, but as a measured loosening. Glaciers thinned at their edges. Meltwater traced new paths across land, and seas began their long return toward familiar shores. The shift unfolded with patience, stretching across generations, gentle enough to feel almost like stillness. As temperatures softened, landscapes settled into calmer patterns. Forests advanced into valleys once shaped by ice, soils deepened, and ecosystems spread with fewer interruptions. Rivers followed steadier courses, and coastlines paused long enough to appear reliable. Winds calmed, seasonal extremes softened, and the constant pressure of cold relaxed. For the first time in a long while, change slowed to a pace that felt manageable. Within this quieter climate, life reorganized itself. Plants and animals adapted to narrower ranges of variation. Migration routes stabilized. Food sources became more predictable. The land itself began to feel dependable, as if it had chosen a shape and intended to keep it. For human communities, this steadiness offered something new, not safety, but continuity. This warmth felt familiar because it aligned with human perception. It matched the scale of memory and experience. Seasons repeated in recognizable ways. Rivers returned each year without surprise. Coastlines remained where they were expected. Within such conditions, planning became possible. Knowledge gained one generation could be passed forward with confidence it would remain useful. Over time, these patterns encouraged permanence. Camps lingered, movements slowed, tools were refined for consistency rather than survival on the edge. Agriculture emerged not as an innovation forced into existence, but as a response to stability that appeared willing to last. The climate did not demand constant adaptation, so societies began to build around the idea of normality. This sense of normal became deeply ingrained because it endured far longer than a lifetime. For many generations, the world behaved in broadly similar ways. The absence of dramatic swings made the climate feel resolved, as if Earth had completed a cycle and settled. The past of advancing ice and collapsing habitats faded into distant memory, carried only in stories that gradually lost urgency. Yet beneath this calm surface, the planet remained unchanged in deeper structure. Ice still anchored itself to the poles. Oceans still circulated according to patterns shaped by cold, and the slow orbital rhythms continued their steady motion. The warmth did not replace the Ice Age framework. It rested within it, allowed by it, constrained by it. Geologically, this warm phase was brief. It represented a pause rather than a conclusion. The systems that governed long-term climate had not been dismantled or reset. They simply occupied a quieter arrangement for a time. The same forces that once deepened cold remained present, waiting patiently as they always had. What made this warmth feel permanent was not its strength, but its duration relative to human experience. Thousands of years can feel endless when measured through lived lives. Stability lasting that long invites assumption. It becomes the reference point against which all else is judged. Change outside that range feels abnormal, even when it is part of a larger pattern. In the planet's deeper timeline, however, this calm was a narrow window, a temporary easing within a long ice age rhythm. Earth had not returned to a default state. It had settled into an interlude defined by balance rather than resolution. The warmth carried no guarantee of continuation. It simply persisted long enough to feel complete. This gentle phase allowed civilization to take root, shaping perception as much as landscape. It offered a world that seemed finished, even as deeper processes continued beneath. In that quiet mismatch between appearance and structure, the warmth felt permanent, though it never truly was, unfolding instead as one calm chapter within a story still guided by ice and time. The calm that settled over the planet did more than soften landscapes. It created conditions that allowed humans to stop moving so often, to stay, to return to the same places year after year with growing confidence. Seasons arrived in familiar order. Rain followed patterns that could be learned. Cold and warmth traded places with enough regularity to be anticipated rather than feared. This reliability did not feel remarkable at first. It simply felt usable. Farming grew quietly from that usefulness. Seeds placed in the ground returned food at roughly the same time each cycle. Soils rested long enough to recover. Floods and droughts still occurred, but not with the relentless unpredictability of earlier ages. The land rewarded patience and planning. Over time, knowledge accumulated, passed forward with the expectation that it would remain relevant. Agriculture depended on this trust, not as a conscious bargain, but as an assumption built into every planted field. As harvests stabilized, populations grew. Villages expanded into towns, towns into cities. Permanent structures replaced temporary shelters. Walls, roads, and storage sites were built with the confidence that the ground beneath them would not be claimed by ice or the sea within a lifetime. Rivers that once wandered widely began to serve as borders and lifelines. The climate's steadiness allowed human organization to grow complex without constant disruption. Coastlines mattered deeply in this arrangement. Ports formed where shores remained predictable. Trade networks relied on seas that rose and fell within narrow limits. Entire economies grew around access to water that stayed where it was expected to stay. The memory of shifting oceans and exposed land bridges faded far into the past. For civilizations rising during this warm phase, the edges of continents felt fixed. This apparent stability shaped human thinking as much as human construction. Time horizons shortened, planning extended years or generations ahead, not millennia. Social systems, laws, and traditions were designed for a world assumed to repeat itself. The climate did not demand frequent reinvention, so permanence became a cultural value. Settlements were meant to last. Fields were expected to feed descendants not yet born. None of this required an explicit belief that the climate was finished changing. The assumption was quieter than belief. It lived in architecture, in calendars, in the way knowledge was stored and institutions were built. Civilization did not declare the climate reliable, it behaved as if it were. This dependence deepened with success. As systems grew more interconnected, flexibility decreased. Irrigation networks, trade routes, and political boundaries all relied on environmental consistency. A predictable climate allowed efficiency, specialization, and surplus. Those gains, in turn, increased reliance on the conditions that made them possible. Stability reinforced commitment to stability. What makes this foundation remarkable is how narrowly it was formed. Civilization rose during a brief easing within a much longer climate pattern. It rested on a state that felt permanent because it endured across human memory, not because it represented Earth's usual behavior. The planet had not abandoned its deeper rhythms. It had simply entered a cooperative moment. The climate did not promise to behave forever. It only behaved long enough for civilizations to take its patterns for granted. Fields were planted closer together, cities expanded outward, coastlines were built upon with little hesitation. Each generation inherited not only structures and knowledge, but the quiet assumption that the environment would remain familiar. This fluke of timing allowed extraordinary cultural growth. Art, science, and shared identity flourished within stable boundaries. Yet beneath this success lay a fragile alignment between human expectations and planetary conditions. Civilization did not adapt to constant change as earlier humans had. It adapted to calm. In doing so, it wove itself tightly into a specific climate state. The steadiness that enabled cities and farms became an unspoken requirement for their survival. The planet offered that steadiness for a time, and humanity built as if it would continue, grounded in a climate that felt dependable, even as deeper systems remained governed by ice, orbit, and time. Even as warmth spread across much of the planet, the ice did not withdraw completely. It remained where sunlight arrived at the weakest angles, where cold could linger without interruption. Vast sheets stayed anchored to the poles, heavy and patient, pressing into the land beneath them. They no longer dominated continents, but they never vanished, and their quiet persistence continued to shape the world above and around them. These ice sheets exist beyond daily experience. They do not announce themselves through changing seasons or familiar landscapes, yet their mass alone alters the balance of the planet. By reflecting sunlight, they reduce the amount of energy Earth absorbs. This effect does not depend on how warm distant regions become. As long as the ice remains, it continues to guide the planet's overall behavior, acting as a steady counterweight to surface warmth. What matters is not whether summers feel gentle or winters feel mild elsewhere. The presence of permanent ice locks Earth into a particular climate state. It defines the baseline around which all other variations occur. Warm periods soften conditions, but do not erase the deeper framework shaped by ice. The planet can feel calm while still being governed by cold structures far from view. These frozen regions also interact constantly with the atmosphere. Cold air forms above ice sheets and flows outward, influencing wind patterns across entire hemispheres. This movement shapes storm tracks, directs moisture, and sets the stage for regional climates thousands of kilometers away. Winds that seem ordinary carry the imprint of ice that remains far to the north or south. The oceans respond in their own slow ways. Cold, dense water forms near the ice margins and sinks, driving deep currents that travel across the globe. These currents move heat between basins, moderating temperatures in some regions while cooling others. Surface conditions may shift, but the deep circulation persists, guided by the existence of cold sources that continue to feed it. Because of this, polar ice affects places that never see snow. Rainfall patterns, ocean productivity, and even long-term weather stability depend on these distant frozen anchors. The ice does not need to advance to exert influence. It simply needs to remain. Its mass and position provide continuity, ensuring that Earth's systems stay connected to their colder roots. This persistence explains why surface warmth can be misleading. Green landscapes and stable seasons give the impression of resolution, yet the deeper system remains unchanged. Ice still controls key feedbacks, still reflects energy, still structures circulation. The planet's appearance has softened, but its foundation has not shifted. Over long spans of time, this anchored ice maintains a kind of memory within the climate. Each cycle of cold and warmth unfolds with reference to what never left. The ice sheets record past atmospheres within their layers, preserve old patterns, and continue to interact with the present. They connect distant eras through their continued presence, bridging what was with what is. Human systems tend to respond to what is visible and immediate. Fields, cities, and coastlines reflect surface conditions. Yet, beneath those familiar settings lies a planet still organized around ice. The continued existence of polar ice matters not because it threatens, but because it defines the range within which all surface stability occurs. As long as ice remains anchored at the poles, Earth does not return to an ice-free state. It continues to behave as a planet shaped by cold, even during warm intervals. Winds and oceans keep their long routes. Energy balances remain tilted. The climate stays within boundaries established long ago. This quiet endurance of ice is easy to overlook precisely because it feels unchanged. It does not demand attention, but it shapes everything. The warmth experienced at the surface rests upon a foundation that never melted away, steady and distant, guiding the planet with a calm authority that persists beneath every gentle season. Within the long rhythm of an ice age, warmth does not disappear. It arrives in intervals that feel generous when they occur, spreading across continents and softening the grip of cold. These periods are known as interglacials, not as opposites of ice ages, but as moments that exist inside them. They are pauses in advance, breaths taken by the planet while the deeper structure remains unchanged. An interglacial begins when shifts in Earth's slow orbital rhythm favor slightly stronger summers at higher latitudes. Snow and ice retreat modestly, allowing darker land and open water to absorb more sunlight. This absorption reinforces the initial warming, spreading gentler conditions across wide regions. Forests expand, seas rise, and climate settles into a calmer pattern that feels expansive and stable compared to what came before. Yet these warm periods are not eras of freedom from ice. Polar sheets remain anchored, continuing to shape winds, oceans, and energy balance. The planet has not reset. It has simply adjusted within limits defined long ago. Interglacials are layered atop an ice age framework, not separate from it. They operate under constraints that quietly determine their duration. Typically, these intervals last thousands of years, long enough for ecosystems to reorganize, for coastlines to hold steady, for rivers to carve familiar paths. Long enough, too, for human societies to experience many generations under similar conditions. In human terms, this length feels immense, stretching beyond memory and recorded history. In planetary terms, it is brief, a narrow band within a much larger pattern. What makes interglacials fragile is the balance they depend on. Their warmth rests on a precise alignment of factors that must persist together. Slight changes in sunlight distribution, atmospheric composition, or ice extent can disrupt that balance. Because ice still exists, feedbacks remain ready, reflection can increase again. Snow can linger longer. Cooling can reinforce itself as readily as warming once did. As orbital rhythms continue their slow progression, the conditions that supported the interglacial begin to fade. Summers lose some strength. Ice retreats less each year. Small differences accumulate quietly until retreat slows and advance resumes. The shift does not feel abrupt. It arrives gradually, almost imperceptibly, as the planet eases back toward colder equilibrium. Interglacials always end because they are not destinations. They are phases within a system inclined towards cycling rather than resolution. The presence of permanent ice ensures that warmth cannot fully disengage from cold. Even at their peak, interglacials carry within them the seeds of their conclusion, embedded in the same mechanisms that allowed them to arise. Life adapts readily to these warm intervals, often flourishing within them. Species spread, habitats diversify, and productivity increases. Yet the temporary nature of these conditions remains woven into the system. Adaptation occurs within limits, shaped by the knowledge, whether biological or cultural, that conditions may shift again. Over deep time, interglacials repeat with recognizable cadence. Each one differs in detail, yet all share the same underlying brevity. None break the cycle, none erase the ice. They offer relief, not release. The planet continues to move through them as part of a larger oscillation guided by forces that operate far beyond surface experience. This is why interglacials feel both generous and uneasy when viewed in context. They provide long stretches of calm without promising permanence. They allow stability while carrying quiet impermanence beneath. Warmth settles in, stays for a while, and then gives way, not because something fails, but because the system has not changed its nature. Interglacials are moments when the planet rests between colder chapters. They are warm enough to feel complete, long enough to feel enduring, yet always temporary. Their endings do not mark catastrophe, only transition, as Earth continues to follow rhythms set in motion long before human memory, steady and unhurried, guided by ice, orbit, and time. The warmth that surrounds the present moment feels steady in a way that earlier generations rarely experienced. Seasons arrive in familiar order, coastlines appear dependable, and landscapes change slowly enough to feel permanent. This steadiness settles into daily life so completely that it becomes background, not something to be noticed, but something expected. The climate seems to agree with human routines, moving at a pace that mirrors memory and habit. What gives this warmth its sense of stability is not only its gentleness, but its duration relative to human lives. Multiple generations can pass under broadly similar conditions. Children grow old without seeing dramatic shifts in temperature or coastline. Knowledge learned early remains useful later. In that continuity, the climate feels resolved, as if it has reached a comfortable arrangement meant to last. Human memory, however, is narrow when placed against Earth's rhythms. What feels ancient to a society may be a brief flicker in planetary time. Oral histories, written records, and even archaeological layers capture only thin slices of climate behavior. They preserve moments, not full cycles. As a result, the range of variation humans consider normal is shaped by a short window, one unusually calm by geological standards. Within that window, the absence of extreme swings becomes a reference point. Calm replaces motion as the expected state. Change, when it appears, feels disruptive rather than routine. This framing does not arise from analysis, but from lived experience. When stability persists long enough, it teaches the mind to treat it as default. Familiarity deepens this effect. Repeated patterns create confidence. Fields produce harvests on schedule. Rivers return to their banks. Winters remain manageable. Over time, this repetition encourages the assumption that what has been will continue to be. The climate does not need to promise consistency. Repetition alone is enough to inspire trust. This confidence settles quietly into infrastructure and culture. Buildings are designed for known conditions. Systems are optimized for typical ranges. Rare events are treated as anomalies rather than signals. The climate's cooperative phase becomes embedded in planning and expectation, shaping decisions long before reflection enters the process. Yet beneath this surface calm, the deeper system remains unchanged. Ice still anchors the poles, orbital rhythms continue their slow shifts, feedbacks remain poised. The planet has not paused its larger motion, it has simply been moving through a gentle interval that aligns well with human perception. The warmth feels stable not because it is permanent, but because it fits neatly inside the span of human awareness. Short memory blurs longer patterns. When each generation inherits similar conditions, the sense of continuity strengthens. The past becomes simplified, remembered as always mild, always workable. Stories of harsher climates fade into abstraction, losing immediacy and weight. Familiarity replaces caution with comfort. This is how false confidence forms, not through error, but through alignment. Human timescales happen to coincide with a calm phase. The match feels reassuring. The climate behaves in ways that support settlement, growth, and complexity. The longer this alignment lasts, the more natural it appears. The warmth feels different because it is experienced from within, not viewed from distance. It surrounds daily life rather than standing apart. Its subtlety allows it to blend into routine, to be felt as normal rather than temporary. The planet has offered a stretch of cooperation long enough for societies to forget that cooperation itself is conditional. In Earth's broader story, this period remains a moment, shaped by forces that continue to operate beyond sight. The sense of stability arises from scale, not conclusion. Familiarity smooths perception, narrowing awareness to what repeats reliably. Within that narrowed view, warmth feels settled and safe, even as deeper rhythms continue their slow, patient movement beneath every predictable season. The oceans carry memory in ways the land cannot. Long after ice retreats from a shoreline or thins at a polar edge, the water remembers what touched it. Cold leaves an imprint that travels slowly, woven into currents that move with patience across the globe. In this way, ice continues to shape the planet far beyond the places where it physically remains. Where ice meets the sea, water grows dense and heavy. Chilled at the surface, it sinks, sliding downward and outward into the deep. This sinking motion pulls warmer water toward the poles to replace it, setting vast circulation patterns into motion. These currents do not rush. They flow steadily, often taking centuries to complete a single loop. Yet they carry enormous influence, redistributing heat, nutrients, and carbon across entire oceans. Because of this circulation, changes near ice margins echo far from their source. A shift in the amount of cold water sinking at the poles alters the speed and direction of deep currents. That change can warm distant coasts or cool them, strengthen rainfall in one region while drying another. The connection is not immediate, but it is persistent, moving through the ocean like a slow pulse. Melting ice does not simply add water to the sea, it freshens the surface, making it lighter and less likely to sink. This can weaken the downward flow that drives circulation, subtly changing the balance between surface and depth. Even modest adjustments near frozen regions can ripple outward, influencing climates thousands of kilometers away through changes in heat transport. The oceans respond as a single, connected system. A disturbance introduced at one pole does not remain local. Currents thread continents together beneath the surface, linking distant basins in quiet exchange. Tropical waters, temperate seas, and polar depths communicate continuously through these pathways. Ice, though limited in area, speaks to the entire ocean. This global reach explains why climates far from ice can still be shaped by it. Rainfall patterns over land depend on how oceans release heat to the atmosphere. Storm tracks follow gradients influenced by sea surface temperatures. Fisheries thrive or decline based on nutrient flows driven by deep circulation. In each case, frozen regions play an unseen role, guiding outcomes far beyond their icy edges. The memory held by the oceans is slow to change. Once circulation patterns adjust, they tend to persist, even if surface conditions fluctuate. Warm years and cool years pass above, while the deep ocean continues its long movement, shaped by cold encounters that may have occurred centuries earlier. This inertia gives the climate system stability, but also means that change, when it comes, unfolds over extended time. Ice strengthens this memory by providing a consistent source of cold. As long as polar ice remains, it continues to feed these deep processes, reinforcing established routes of circulation. The oceans grow accustomed to its presence, organizing their flow around it. Removing that influence entirely would require not just surface warmth, but the unraveling of patterns that have developed over immense spans of time. Through this lens, the oceans become archives as much as engines. They record the influence of ice within their layers, preserving it in temperature gradients and chemical signatures. Each current carries traces of where it has been, of the conditions that shaped it. The water itself becomes a storyteller, moving the past into the present. The reach of frozen regions extends quietly across the planet through these watery pathways. Ice does not need to advance to exert control. Its interaction with the oceans is enough. By shaping circulation, it governs the distribution of warmth and cold, connecting distant climates into a single system that moves as one. In this way, the oceans remember the ice even when the surface appears calm. Beneath waves that reflect peaceful skies, deep currents continue to carry the influence of frozen places. The planet remains interconnected by water shaped by cold, steady, and enduring, linking every shore to the quiet power of ice that still lingers at the edges of the world. The planet's surface bears quiet evidence of the cold that once moved across it. Long after ice retreated, its work remained etched into stone. Glaciers did not merely cover land, they reshaped it, pressing, grinding, and sculpting with slow certainty. What appears natural and timeless today was often forged by motion that unfolded grain by grain beneath immense weight. As glaciers advanced, they flowed like frozen rivers, adapting to the shape of the terrain while steadily changing it. Mountains were not spared. Ice climbed their slopes, rounding sharp peaks into broader forms, carving cirques near their summits, and pulling loose rock downward with it. Valleys that once followed the narrow paths of rivers were widened and deepened into broad U-shaped corridors. These forms did not arise from sudden force, but from persistence applied over vast spans of time. When the ice thickened, it carried stones embedded within it, turning the glacier into a moving tool. Rock scraped against rock beneath enormous pressure, smoothing some surfaces while gouging others. Layers were removed, transported, and deposited far from their source. The land learned to yield gradually, reshaped not by collapse, but by abrasion repeated until resistance softened. As the climate eased and glaciers retreated, they left behind signatures of their passage. Depressions filled with meltwater became lakes, often elongated and deep, reflecting the path of the ice that carved them. Moraines marked the former edges of glaciers, ridges of stone quietly recording where frozen fronts once paused. Plains flattened by ice spread outward, rich with fine sediments ground from distant mountains. Many familiar landscapes owe their existence to these processes. Rolling hills, fertile valleys, and intricate lake systems all carry the influence of cold. Even regions that now feel gentle and stable were once shaped by pressure and movement beyond easy imagination. The scenery that invites rest and reflection was often born from grinding endurance rather than calm growth. Rivers, too, follow routes defined by ice. Meltwater carved channels into newly exposed ground, sometimes redirecting entire drainage systems. As glaciers withdrew, they left behind pathways that water continued to follow long afterward. In this way, ice guided the future as much as it erased the past, setting the course for ecosystems and human settlement alike. The scars of cold remain visible not because they are dramatic, but because they are durable. Smooth bedrock surfaces, striations etched into stone, and valleys disproportionate to the rivers they hold all speak of forces no longer present, yet still influential. These features do not fade quickly. They persist through warmer eras, carried forward as quiet testimony. Over time, vegetation softened their outlines. Forests grew, soils formed, and life filled the spaces left behind. Yet beneath roots and streams, the underlying shapes endure. The land remembers its time under ice even as it supports new forms of life. Each landscape becomes a layered record, blending past and present into a single surface. This enduring influence alters how the planet responds to later change. Mountains shaped by glaciers direct wind and weather. Lakes carved by ice affect local climates and biodiversity. Valleys determine where people travel, farm, and build. The marks left by cold continue to shape patterns long after the ice itself has gone. In this way, Earth carries its history openly. The cold did not merely pass through, it rearranged the terrain in lasting ways, leaving forms that feel natural because they have been present for so long. The planet still wears these traces, not as wounds, but as structure, reminders that even gentle landscapes can be the result of immense patience applied over deep time. The scenery experienced today is not only the product of warmth and growth, it is the outcome of cold that once moved steadily across the world, shaping mountains, valleys, and lakes with slow resolve. The ice may have withdrawn, but its influence remains written into the land, guiding the planet quietly, enduringly, beneath every familiar horizon. Ice has never acted as a simple backdrop to Earth's climate. Once it became permanent, it took on a quieter role, regulating rather than dominating. By existing steadily at the poles and in high elevations, ice dampened the planet's swings, absorbing excess change and releasing it slowly. It did not stop variation, but it softened the edges, guiding Earth away from extremes that might otherwise have arrived more abruptly. One way ice achieves this is through its influence on energy balance. Frozen surfaces reflect a significant portion of incoming sunlight, preventing rapid warming when solar input increases. At the same time, ice stores cold efficiently, releasing it gradually as conditions shift. This dual action slows both heating and cooling, creating a form of inertia within the climate system. Changes still occur, but they unfold with measured pace rather than sudden force. Ice also interacts deeply with the movement of air and water. Cold regions encourage the formation of dense air masses that circulate outward, helping distribute energy across latitudes. In the oceans, ice fosters the formation of deep, cold currents that carry heat away from some regions and deliver it to others. Together, these processes smooth contrasts between equator and pole, preventing sharp imbalances from building too quickly. Because of this, ice functions like a planetary governor. It does not decide direction, but it controls speed. Climate trends that might otherwise accelerate are moderated, stretched across longer spans of time. Warm periods lengthen, without becoming runaway. Cold phases deepen without freezing the planet entirely. This steadying effect creates room for life to adapt rather than react. Frozen water also stabilizes chemical cycles. Ice locks away fresh water, influencing sea level and salinity in predictable ways. It preserves atmospheric records within its layers, buffering sudden changes in composition. By slowing exchanges between air, ocean, and land, ice helps maintain equilibrium across systems that would otherwise fluctuate more violently. Over deep time, this regulation has shaped the trajectory of life itself. Evolution unfolded under conditions that changed, but not too rapidly. Ecosystems learned to adjust to cycles rather than collapse under shocks. Even mass shifts occurred within frameworks that allowed recovery. Ice did not guarantee gentleness, but it reduced volatility, yet regulation depends on balance. Ice stabilizes only while it remains present in sufficient form. Its ability to reflect sunlight, drive circulation, and store cold relies on continuity. When ice diminishes, these moderating effects weaken. Energy is absorbed more readily. Feedbacks accelerate instead of restraining change. The climate becomes more responsive, less buffered. As frozen regions shrink, transitions that once unfolded slowly can begin to move faster. Temperature shifts propagate more directly. Ocean circulation patterns adjust, sometimes unevenly. Atmospheric systems respond with greater variability. The regulator loosens its grip, not catastrophically, but incrementally, altering how the planet handles change. This shift does not mean immediate instability. Earth has operated without permanent ice before, but those worlds function differently, with broader warmth and fewer constraints. The stabilizing influence that ice provides belongs specifically to Ice Age climates. Removing it moves the planet toward another mode, one governed by different feedbacks and rhythms. Understanding ice as a regulator reframes its importance. It is not merely a remnant of cold eras, nor a passive indicator of climate state. It is an active participant, shaping how quickly and how far Earth can move in response to forcing. Its presence creates patience within the system. As long as ice remains, the planet retains this quiet moderation. Extremes are tempered, change is spread across time. Life continues to operate within familiar boundaries. When that balance shifts, the nature of change shifts with it, becoming less restrained, more immediate. Ice does not rule Earth's climate, but it steadies it. Through reflection, circulation, and storage, frozen water has acted as a long-term regulator, guiding the planet through cycles with restraint rather than force. Its role is subtle, enduring, and deeply embedded, shaping not just what the climate becomes, but how quickly it is allowed to change. The phrase Ice Age carries a heavy image. It conjures frozen worlds, endless snow, towering walls of ice, and animals moving through blizzards beneath gray skies. This picture has settled deeply into culture, shaped by art, stories, and imagination. It feels dramatic, complete, and absolute. Yet the scientific meaning behind the words is quieter, broader, and far less rigid than the image suggests. In science, an ice age is not defined by constant cold or a world buried in ice. It is defined by structure rather than scenery. As long as permanent ice exists somewhere on the planet, Earth occupies an ice age climate state. Warm periods, forests, oceans, and green landscapes are not contradictions to this state. They are features that unfold within it. The cultural image focuses on extremes, while the scientific reality is built around persistence. Mammoths have become the symbol of ice ages for this reason. Their thick fur and curved tusks fit neatly into the frozen imagery people expect. They represent survival against cold, movement through snow, and life under harsh conditions. Yet mammoths lived during both colder and warmer intervals. They did not exist because the entire world was frozen, but because climate fluctuated within an ice age framework. Focusing on such animals narrows attention toward spectacle rather than system. It pulls the eye toward moments of maximum cold instead of the processes that define climate over long spans of time. Ice ages become imagined as events rather than states, as disasters rather than patterns. This shift in emphasis makes it difficult to recognize quieter truths unfolding around warmer periods. Language plays a powerful role here. The words ice age suggest uniformity and finality, as if the planet enters a frozen chapter and then leaves it behind. In reality, climate states overlap warmth and cold, motion and pause. Ice ages contain interglacials, long stretches of calm warmth, and gradual transitions. The phrase fails to convey this complexity, encouraging a simplified mental model. Because of this, warmth is often interpreted as an ending. When temperatures rise and ice retreats, it feels intuitive to say the ice age is over. The phrase itself leads thought in that direction. Yet, from a scientific perspective, the deeper conditions have not changed. Ice remains, feedbacks persist, and long-term rhythms continue their movement. The planet has softened, not reset. This mismatch between language and meaning shapes public understanding. If ice ages are imagined as fully frozen worlds, then recognizing the present as part of one feels counterintuitive. Green landscapes, open oceans, and mild climates appear to disprove the idea. The language sets expectations that reality does not meet. Scientific understanding, by contrast, emphasizes mechanics. It looks at energy balance, ice persistence, circulation patterns, and orbital rhythms. These elements operate quietly beneath surface appearance. They define climate states through continuity, not through visible extremes. When viewed through this lens, the presence of permanent ice carries far more significance than how warm a given region feels. The misleading nature of the phrase does not come from inaccuracy, but from incompleteness. It captures one aspect of the climate state while hiding others. It foregrounds cold imagery while obscuring the structure that allows warmth to exist within the same framework. In doing so, it encourages a binary way of thinking about climate that does not match how the planet actually behaves. Understanding this gap between language and reality opens space for deeper awareness. It allows the present to be seen not as an exception, but as a phase, not as a contradiction, but as part of a larger pattern. The words used to describe Earth shape what is noticed and what is overlooked. The phrase ice age remains useful, but only when its limits are understood. Beneath the imagery of mammoths and glaciers lies a system defined by persistence, rhythm, and balance. Language tends to simplify what science reveals as layered and continuous. Recognizing that difference helps the deeper truths come into view, quietly reshaping how Earth's long story is understood. When the definition of an ice age is viewed through the lens of deep time, it begins to settle into clarity. Scientists do not look for frozen continents or endless snow. They look for continuity. They ask whether ice exists somewhere on the planet year after year, surviving warmth, resisting complete disappearance. This persistence, rather than spectacle, is what defines the state Earth inhabits. An ice age, in scientific terms, begins not when glaciers advance dramatically, but when ice first becomes permanent. Once frozen water remains anchored at the poles through every season, the planet enters a different mode of behavior. Energy balance shifts, circulation patterns reorganize, feedbacks take hold. From that moment on, Earth no longer behaves like a fully ice free world, even during long, warm periods. This definition feels understated because it does not rely on extremes. It does not require the presence of ice everywhere, only somewhere. A single enduring reservoir of ice is enough to alter planetary systems. That ice reflects sunlight, cools surrounding air, and drives deep ocean circulation. It introduces memory and restraint into the climate, ensuring that cold never fully releases its influence. By this measure, warm intervals do not end an ice age, they exist within it. Forests may spread, seas may rise, and climates may soften, yet the deeper structure remains intact as long as permanent ice survives. The planet oscillates gently, but it does so around a cold, anchored center that continues to shape every cycle. Seen this way, the definition stops feeling abstract and begins to align with what has already been observed. The poles still hold massive ice sheets. They have not vanished through the warmth of recent millennia. They continue to interact with the atmosphere and oceans, guiding winds, currents, and energy flows. The conditions that define an ice age remain present, even though surface environments feel mild. This realization does not arrive with drama. It arrives quietly, through accumulation of evidence rather than revelation. Ice cores record long continuity. Sediments confirm persistent circulation. Models show feedbacks that depend on frozen regions. Together, these lines of understanding converge on the same conclusion without announcement or urgency. The present becomes included not because it resembles ancient cold extremes, but because it shares the same underlying structure. Earth today still operates within boundaries established when ice first refused to melt away entirely. The calm climate experienced now rests within that framework rather than outside it. This perspective reframes warmth itself. Instead of signaling escape from an ice age, warmth becomes one phase within it. Interglacials are not departures, but pauses. They soften conditions without dismantling the systems that produce long-term cycling. The ice age does not end, it breathes. What once felt like a contradiction begins to resolve. A green world with cities and farms can exist within an ice age because the definition was never about surface appearance. It was always about persistence. Permanent ice is the quiet marker that carries more weight than temperature averages or seasonal comfort. When this definition settles into place, it connects the past to the present seamlessly. There is no abrupt boundary where one world ends and another begins. Instead, there is continuity. Ice appeared, endured, and reshaped planetary behavior. Everything since has unfolded within that context. Understanding this removes the need for dramatic endings or beginnings. Earth did not exit an ice age in recent history. It entered one long ago and has been moving through its rhythms ever since. The present belongs to that story, not as an exception, but as a chapter shaped by the same conditions that have guided the planet for millions of years. In that quiet alignment between definition and observation, the concept finally makes sense. The Ice Age is not something that happened once and ended. It is something Earth is still living inside, steady and unassuming, defined not by how cold the world feels, but by the ice that never left. Daily life unfolds at a scale where the deeper climate state remains out of view. Mornings arrive with familiar temperatures, afternoons pass under steady skies, and seasons follow patterns learned early and repeated often. These rhythms feel complete because they are close, immediate, and reliable. The larger system that holds them in place moves far more slowly, operating beneath perception like a current beneath a calm surface. The reason cold feels absent is not because it no longer matters, but because its influence has retreated into structure rather than sensation. Ice sits far from most human settlements, anchored at the poles and high elevations. Its presence shapes winds, oceans, and energy balance, yet it does so quietly, without demanding attention. What is distant is easily forgotten even when it governs the whole. Scale plays a powerful role in this separation. Human experience is measured in days, years, and lifetimes. Climate states unfold across thousands or millions of years. Within such disparity, the signals of deep climate blend into background. Subtle influences become invisible when stretched across spans too long to feel. The Ice Age remains active, but its movements fall outside the frame through which daily life is viewed. Time conceals pattern just as distance conceals cause. A few centuries of stability feel complete when passed through stories, records, and memory. The repetition of similar seasons builds confidence that the present arrangement is settled. Fluctuations smaller than that feel like noise rather than structure. Longer cycles, unfolding patiently, slip beneath awareness entirely. This mismatch creates a sense of independence. Daily life appears self contained, shaped by local weather rather than planetary systems. Fields respond to rain, cities respond to temperature, and people respond to comfort or discomfort. The deeper drivers remain abstract, sensed only through science or history rather than lived experience. As a result, the climate state feels disconnected from the routines it supports. The Ice Age persists, not as an ever present cold, but as a framework that defines limits. It sets the boundaries within which warmth and calm are allowed to exist. Because these boundaries are wide enough to accommodate comfort, they remain unnoticed. The absence of immediate constraint creates the illusion of freedom from deeper structure. Time reinforces this illusion. Patterns that repeat slowly appear flat when viewed briefly. A cycle spanning tens of thousands of years looks like constancy across a handful of generations. Change that unfolds gradually registers as normal variation rather than direction. The mind, trained to notice contrast, relaxes into sameness. This perspective is not error, but adaptation. Human awareness is tuned to scales that matter for survival and decision making. It excels at reading weather, seasons, and short term trends. It is less suited to tracking motions that complete a turn over millennia. The planet's long rhythms were never meant to be felt directly. Yet those rhythms continue regardless of perception. Ice grows and thins. Oceans adjust their circulation. Energy balances shift incrementally. None of this disrupts a single day. It reshapes centuries. The climate state persists as a slow context rather than an event. Living inside an ice age without feeling cold becomes possible because comfort exists within structure. Warm periods, stable coastlines, and predictable seasons occupy a space allowed by deeper conditions. They do not erase them, they rest within them. The sense of separation between daily life and climate state arises from this layering. Surface experience floats above long-term processes like leaves on water. The motion beneath carries them along even when it cannot be felt. This is how scale hides reality. This is how time hides pattern. The Ice Age remains present not as constant cold, but as quiet continuity. It shapes the planet patiently while daily life unfolds in warmth, giving the impression of independence, even as it moves within boundaries set long ago. The transition into warmth did not bring closure. It brought quiet modification. The planet did not abandon its deeper climate state, nor did it dismantle the systems shaped by long-lasting ice. Instead, warmth settled across the surface like a gentler season layered atop an older foundation. The cold did not leave. It stepped back, remaining present in structure rather than sensation. Surface warmth changes what is visible. Forests spread, soils deepen, coastlines stabilize, and ecosystems flourish with fewer interruptions. These changes feel decisive because they transform daily experience. The world looks calmer, more hospitable, more complete. Yet these qualities belong to the surface layer of climate, not to its underlying architecture. Beneath that surface, ice continues to exist as a structural feature. Anchored at the poles and high elevations, it still reflects sunlight, drives circulation, and shapes energy balance. These processes operate regardless of how comfortable conditions feel elsewhere. Ice remains woven into the climate system, holding together feedbacks that define long-term behavior. This distinction between surface and structure explains why the Ice Age did not truly end. Ending would require complete removal of permanent ice, a full release from the feedbacks it sustains. That never happened. Instead, the planet entered a state where warmth expanded without erasing what lay beneath. The climate softened its expression while retaining its framework. Warmth, in this context, functions like a temporary covering. It smooths contrasts, reduces extremes, and allows stability to emerge for long stretches of time. Yet it does not rewrite the rules governing planetary response. Those rules continue to be enforced by ice that persists quietly, shaping circulation, moderating change, and anchoring climate rhythms. Appearance plays a powerful role in perception. A green world with mild seasons appears resolved. The lack of advancing glaciers or collapsing ecosystems gives the impression that the planet has moved on. Surface signals dominate awareness because they are immediate and tangible. Structural signals operate at scales that do not announce themselves. Reality, however, unfolds beneath appearance. Ice still defines the baseline. Orbital cycles continue to modulate climate within boundaries set by frozen water. Oceans and winds respond to cold sources that remain active. The deep system behaves as it always has since ice became permanent, even while the surface expresses calm. This layering allows two truths to exist at once. Life experiences warmth and stability. The planet continues to operate within an ice age state. The softness of one does not contradict the persistence of the other. They coexist, each influencing different layers of the same system. Over time, this coexistence has shaped expectation. Humans experience only the softened surface and build around it. Structures, traditions, and assumptions form based on what is seen and felt. The deeper structure becomes abstract, a concept rather than a presence. The Ice Age feels like history rather than context. Yet the context remains active. Ice continues to regulate the pace of change, slow extremes, and guide long-term cycles. It shapes the future as much as it shaped the past. The softened phase does not remove this influence, it simply masks it. Understanding this separation clarifies why the Ice Age did not end. Nothing fundamental was dismantled. The scaffolding remained in place while the surface settled into calm. The climate did not escape its long-term pattern. It expressed one of its gentler forms. This is the quiet truth beneath modern warmth. The planet did not transition from one state to another. It adjusted its surface conditions within an existing state. The Ice Age softened rather than concluded, allowing warmth to flourish temporarily without surrendering its deeper structure. Appearance shifted, reality endured. Across the immense span of Earth's history, warmth has not been the rule. It has appeared at intervals, lingered, and then faded, while cold has returned again and again with quiet reliability. The planet's long memory, written into stone, ice, and sediment, reveals a tendency toward cooler states, punctuated by brief softenings rather than sustained heat. This preference is rooted in how Earth balances energy. The planet receives sunlight unevenly, concentrated near the equator and thinning toward the poles. Without strong mechanisms to redistribute and retain that heat, cooling gains an advantage. Over deep time, the growth of ice, the rearrangement of continents, and the evolution of atmospheric composition have all tipped that balance toward conditions where cold can persist. Once ice takes hold, it reinforces this tendency, reflecting light and guiding circulation in ways that favor its own survival. Warm periods do occur, but they require alignment. Greenhouse gases must remain elevated. Ocean currents must transport heat efficiently, and polar regions must avoid long-term ice buildup. These conditions can be met, but they are delicate. Small shifts can undo them. When warmth wanes, it does so not because something breaks, but because the supporting balance no longer holds. Cold, by contrast, is easier to maintain once established. The geological record shows this contrast clearly. Ice-free worlds exist, but they occupy limited chapters. They are separated by long stretches where ice persists at one or both poles. Even during eras considered warm, evidence often points to cooler intervals embedded within them. The planet oscillates, but the oscillation leans toward cold as a resting state rather than an anomaly. Warmth stands out precisely because it feels generous. It allows forests to spread, seas to rise, and life to diversify across broad ranges. These phases support complexity and abundance, leaving rich traces in fossils and landscapes. Their visibility gives them weight in perception, yet their duration remains short relative to the colder frameworks that surround them. Stability arises most clearly during these warm intervals, and that clarity can be misleading. Calm climates give the impression of completion, as if the planet has settled into an equilibrium. For life forms experiencing such periods, consistency becomes familiar and expected. Over generations, this familiarity hardens into assumption. The climate appears steady because it remains within narrow bounds long enough to be trusted. Viewed from deep time, however, that trust rests on a fragile moment. Stability is not a permanent feature of Earth's climate. It is an emergent property that appears when multiple forces briefly align. When those forces drift, as they inevitably do, stability dissolves quietly. The planet does not shatter, it shifts. Cold's dominance does not imply hostility. It reflects inertia. Once cooling processes engage, they persist with little encouragement. Ice amplifies itself, circulation adjusts, and energy balance settles into patterns that resist rapid reversal. Warmth must continually be maintained. Cold maintains itself. This dynamic makes stability an illusion born of scale. Within human memory, a few thousand years of calm can feel enduring. Within geological time, it is a blink. The planet's deeper tendencies remain unchanged by such brief intervals. They wait, patient, until conditions again favor their expression. Understanding Earth's climate preference reframes expectation. Warmth becomes a visitor rather than a resident. Stability becomes a phase rather than a destination. The long arc of the planet bends toward cooler states, interrupted by moments of softness that feel expansive precisely because they are rare. Earth continues to offer these moments, allowing life to flourish and complexity to grow. Yet beneath that generosity lies a quieter truth. The planet does not aim for permanence. It moves through states shaped by physics, feedbacks, and time. Cold dominates not by choice, but by consequence. Warmth arrives, rests briefly, and then yields, leaving behind the enduring lesson that stability, however convincing, has always been temporary. For Earth to fully leave its current ice age state, the planet would need to undergo a profound and sustained transformation. Ice would have to disappear, not just from coastlines or mountain ranges, but from the poles entirely. Every remaining ice sheet would need to melt away and fail to return through repeated seasonal cycles. Only then would the structural anchors that define an ice age release their hold. Such a change would require warmth that is both intense and enduring. Temperatures would need to remain high enough for thousands of years to overwhelm the feedbacks that preserve ice. Reflection would have to give way to absorption. Snow would need to melt faster than it could accumulate. Ocean circulation would need to reorganize without cold sources feeding its deep currents. This is not a short surge of warmth, but a long, steady shift in planetary balance. Earth has accomplished this before. Deep in the past, during certain greenhouse periods, no permanent ice existed anywhere on the planet. Polar regions supported forests. Sea levels stood far higher than today. Atmospheric composition, continental arrangement, and ocean circulation aligned in ways that prevented ice from gaining a foothold. Those worlds operated under entirely different constraints, with heat redistributed efficiently and cooling feedback suppressed. These ice-free states, however, were not accidental. They emerged from specific combinations of conditions that persisted for immense spans of time. Carbon levels remained elevated. Continents were positioned to favor uninterrupted ocean flow. Polar regions received enough warmth year-round to resist freezing. Once those alignments shifted, ice returned, and with it a new climate regime. What makes a full exit from the current ice age unlikely in the near future is not the impossibility of warmth, but the resilience of ice once it exists. Today's ice sheets occupy regions that receive little sunlight even under warmer conditions. Their height, thickness, and reflective surfaces reinforce their survival. Even substantial warming struggles to erase them completely, because each retreat exposes conditions that favor return. In addition, Earth's orbital rhythms continue to favor periodic cooling. These slow cycles persist regardless of surface conditions, nudging the climate back toward ice growth over long spans of time. As long as ice remains during these cycles, it regains strength during cooler intervals. The feedbacks reset rather than disappear. Ocean circulation also works against rapid ice loss. Cold, dense water formed near ice margins continues to drive deep currents that redistribute heat away from the poles. This ongoing transport helps preserve colder conditions where ice already exists. Removing that influence would require a fundamental restructuring of the oceans themselves, something that unfolds slowly and rarely. Even atmospheric changes operate within constraints shaped by ice. While greenhouse gases can raise global temperatures, eliminating every last remnant of polar ice requires more than increase alone. It requires persistence across many thousands of years without interruption by cooling phases. Any pause allows ice to stabilize and recover. This does not mean Earth is locked permanently into its current state. Over deep time, conditions will change again, continents will drift, atmospheric composition will evolve. The sun itself will grow brighter. Given enough time, The planet may once more shed its ice entirely, but such transitions belong to scales far beyond immediate horizons. For now, Earth remains within an ice age framework, softened by warmth rather than erased by it. The ice holds its ground, quiet and enduring, maintaining the structures that define planetary behavior. Leaving this state would require not just heat, but a sustained reworking of feedbacks that have been active for millions of years. The possibility exists, proven by history, yet distance in time makes it remote. Earth can leave an ice age, but it does so slowly, reluctantly, and only when every condition aligns for long enough to let the last ice finally fade without return. The conditions that allowed civilization to take root exist within a surprisingly narrow range. Temperatures must remain neither too cold nor too warm. Precipitation must follow dependable patterns, and seasons must arrive in rhythms gentle enough to anticipate. This balance does not require perfection, but it does require consistency. Within this window, crops grow reliably, rivers flow predictably, and coastlines remain stable long enough for generations to build upon them. What makes this window fragile is how little it takes to shift its edges. Civilization depends not on average conditions alone, but on the regular return of familiar ones. A slight change in rainfall timing alters planting cycles. A modest rise in sea level redraws coastlines. A subtle shift in temperature changes where ecosystems can function. These variations do not need to be dramatic to matter. They only need to persist. The planet does not move in large steps. It adjusts through accumulation. Small differences compound over time, nudging systems into new patterns. A minor imbalance in heat distribution alters winds. Changed winds reshape ocean surfaces. Oceans, in turn, influence weather far inland. Each adjustment feeds the next, not abruptly, but steadily, until the landscape people depend on no longer behaves as expected. Civilization evolved to thrive within a calm interval where these feedbacks aligned favorably. That alignment allowed specialization, permanence, and complexity to flourish. Food production became predictable. Trade expanded along reliable routes. Infrastructure assumed continuity. These achievements rest on a climate that cooperates quietly in the background. Because this cooperation has lasted longer than a single lifetime, it can feel assured. Repetition breeds trust. When conditions remain within familiar bounds, they fade into assumption. The climate becomes something worked around rather than worked with. Yet this confidence rests on a moment rather than a rule. The deeper climate system is capable of shifting without regard for human schedules. Its rhythms unfold over spans that do not synchronize with social structures. When conditions drift, they do so gradually enough to resist immediate notice, yet firmly enough to reshape outcomes over centuries. The change does not arrive as catastrophe, but as mismatch, a growing gap between expectation and reality. Small changes matter because they push systems toward thresholds. Soil moisture crosses a point where crops fail more often. Snowpack falls below levels needed to sustain rivers through dry seasons. Storm tracks shift just enough to strain infrastructure designed for older patterns. Each step alone may seem manageable. Together, they redefine what is possible. The fragility of this window does not imply imminent collapse. It reflects sensitivity. Civilization is tuned to a particular climate arrangement, one that supports its complexity. Alter that arrangement too far or too fast, and adaptation becomes harder. Systems built for stability struggle when variability increases, even modestly. Stability, in this sense, is not a permanent state. It is a condition maintained by balance. When balance shifts, stability dissolves quietly. The planet does not need to become hostile. It only needs to become less predictable. That unpredictability challenges assumptions embedded in agriculture, infrastructure, and governance. This does not mean the planet is failing. It is behaving as it always has, moving through states shaped by physics and feedbacks. The fragile window exists because conditions happen to align in a way that favored human development. That alignment carries no guarantee of duration. Understanding this fragility invites perspective rather than fear. It places civilization within Earth's broader story rather than above it. The narrowness of the window highlights both opportunity and limitation. Humanity flourished within a rare interval of calm, supported by a climate that cooperated long enough to feel permanent. The truth is quieter than urgency suggests. Stability is a phase, not a promise. Small changes matter because they accumulate. The window exists because balance exists. As the planet continues its slow movement, that balance will shift, not abruptly, but inevitably. Civilization depends on recognizing the delicacy of the conditions that carried it this far, grounded in the understanding that the calm it inherited was always fragile and never guaranteed. Ice does not simply sit in place, it accumulates, layer by layer, year after year, quietly recording the conditions of the world above it. Each snowfall compresses the air beneath, sealing tiny pockets of atmosphere into solid form. Over time, these layers become a vertical archive, stretching downward through centuries and millennia, preserving moments that would otherwise vanish without trace. Within this frozen archive, the planet's past remains intact. Gases that once drifted freely through ancient skies are held still, trapped as bubbles no larger than grains of sand. Dust from distant eruptions, ash from wildfires, and particles carried by long forgotten winds settle into the ice alongside snow. Nothing is rushed, nothing is rearranged. The cold locks each signal into place exactly as it was when it fell. As layers build, time becomes visible. Thicker bands mark years of heavy snowfall. Thinner ones reflect leaner seasons. Subtle changes in color and texture tell stories of shifting temperatures and changing circulation. The ice does not interpret these signals. It preserves them faithfully, waiting for discovery. What was once atmosphere becomes record, transformed by pressure and patience. Frozen water remembers conditions far beyond human memory. It carries evidence of warmer intervals and deeper cold, of stable stretches and abrupt shifts. Changes in greenhouse gases appear gradually through the layers, revealing long trends rather than sudden jumps. Variations in isotopes trace temperature changes with remarkable sensitivity. Together, these signals form a continuous narrative, uninterrupted across spans no written history could approach. This memory gives scientists a rare ability to see climate as process rather than event. Instead of isolated moments, the ice reveals transitions. It shows how long warmth endured, how quickly cooling took hold, and how systems responded over time. The record is not dramatic, it is steady, detailed, and precise. It reflects the slow language of the planet itself. What makes ice unique as a record is its quiet honesty. It does not exaggerate, it does not smooth over complexity. Each layer exists because conditions allowed it to exist. When snowfall increased, the layers thickened. When conditions shifted, the chemistry changed. There is no intent, only preservation. Melting alters this relationship with time. When ice disappears, its memory dissolves with it. Layers collapse into liquid. Trapped gases are released back into the air, no longer marked by age or order. The archive becomes unreadable. What once existed as a sequence of preserved moments blends into the present atmosphere without distinction. This loss is irreversible. Once melted, the exact arrangement of layers cannot be restored. The specific combination of gases, dust, and structure that defined a past year is gone. The information does not vanish entirely, but it becomes dispersed, mixed into the broader system, stripped of its context. The story remains incomplete. Ice does not only remember climate, it remembers stability and change. It records how long conditions persisted before shifting and how quickly those shifts occurred. In this way, ice becomes a reference, a measure of how the planet behaves when left to its own rhythms. It captures the pace of Earth's breathing, slow and deliberate. As long as ice remains, this memory continues to accumulate. Each year adds another page to a book written without words. The deeper the ice, the further back the story reaches. What is preserved is not just data, but continuity, a connection between past and present that allows understanding to extend beyond lived experience. When ice melts, the present grows louder, but the past grows quieter. Frozen water remembers patiently, melting erases silently. In that contrast, ice stands not merely as a climate feature, but as time itself held still, offering its memory only as long as it remains frozen. Human time unfolds in short arcs. Lives are measured in decades, memories in years, plans in seasons. Change feels significant when it alters a lifetime, and urgency emerges when it reshapes a generation. Within this frame, even slow motion appears fast. A few decades can feel immense because they contain beginnings, endings, and everything in between. This sense of scale is not a flaw, it is an adaptation. Attention evolved to focus on what can be acted upon within a human lifespan. Patterns that repeat across childhood and adulthood become familiar anchors. Stability is judged by whether conditions remain similar from one generation to the next. When they do, the world feels settled. Planetary time operates under entirely different rules. Geology measures change through accumulation rather than moments. Mountains rise grain by grain. Oceans rearrange themselves over millions of years. Ice advances and retreats across spans so long that individual years lose distinction. What feels permanent to humans often barely registers at this scale. In geology, decades are thinner than a line in stone. They pass too quickly to leave clear marks. Even centuries, which carry the full weight of recorded history, are little more than flickers. The planet responds not to brief episodes, but to persistent conditions that endure long enough to reshape structure. This difference creates a fundamental mismatch. Humans look for change that arrives quickly and announces itself clearly. The planet changes slowly, quietly, and without emphasis. Its most important transitions occur without drama, unfolding beneath awareness. By the time they become obvious, they have often been underway for far longer than memory can reach. Because of this, misunderstanding takes root easily. Short-term stability is mistaken for permanence. Gradual shifts are dismissed as background variation. When nothing seems to change from year to year, it feels reasonable to assume nothing meaningful is happening at all. Planetary processes exploit this assumption simply by being patient. Ice ages illustrate this mismatch clearly. Their defining transitions occur across thousands of years. To human perception, such spans blur into continuity. Warmth or cold that persists for generations feels like a fixed state rather than a phase. The deeper cycle remains invisible until viewed through records that extend far beyond lived experience. This gap between scales shapes intuition. People expect systems to respond within familiar timeframes. When they do not, those systems appear stable. In reality, they may be adjusting steadily, imperceptibly, toward a different configuration. The absence of immediate feedback reinforces false confidence. Geology does not rush. It responds when thresholds are crossed, not when patience runs thin. Heat accumulates, ice thickens or thins, pressure builds. Once conditions persist long enough, change follows, often rapidly by geological standards, even though it began long before. Human time struggles to register this process because it lacks reference points. Without markers spanning thousands of years, slow motion looks like stillness. Memory resets every generation. Stories reach back only so far. What came before fades into abstraction. Science bridges this gap by extending perception beyond direct experience. Ice cores, sediments, and fossils compress immense spans into readable form. They reveal that what feels sudden in human terms is often the culmination of a long, quiet buildup. They translate planetary time into something closer to understanding. The mismatch between human time and planetary time does not imply error on either side. Each operates according to its needs. Humans navigate immediate survival and meaning. The planet responds to physics and feedbacks without regard for perception. Misunderstanding arises when one scale is mistaken for the other. Decades feel long because they contain entire lives. To geology, they are moments that pass without consequence. Recognizing this difference allows perspective to widen. It places human experience within a much larger rhythm, where change does not hurry, but it does not pause. The planet continues its motion steadily, while human time moves quickly across its surface, feeling immense even as it barely leaves a trace. Knowledge unsettles not by force, but by rearrangement. It shifts the position of familiar things, placing them within a larger frame where they no longer stand alone. When the present is seen against the depth of Earth's history, it loses the appearance of permanence. What once felt stable begins to look provisional, held in place by conditions that may not last. This reframing does not remove meaning from the present, it simply loosens its edges. The world people inhabit still exists, still matters, still carries weight. Yet it becomes one moment among many rather than a final state. The calm that surrounds daily life is revealed as a phase, supported by balance rather than guaranteed by design. That awareness changes how the present is held. Much of what feels normal is built on repetition. Seasons arrive on schedule, landscapes behave as expected, coastlines stay where maps say they should be. These patterns shape instinctive assumptions about how the world works. When knowledge exposes the fragility of those patterns, it does not erase them, but it alters their context. Normalcy depends on familiarity. It grows stronger as experiences repeat without interruption. Over time, familiarity transforms into belief. The climate feels steady because it has been steady within memory. The environment feels reliable because it has responded predictably. This confidence forms quietly, without reflection. Learning that such stability is neither universal nor enduring challenges that confidence. It reveals that what feels ordinary is supported by conditions that could shift. The present stops feeling like a baseline and begins to resemble a narrow ledge within a much larger terrain. This realization arrives gently, yet it lingers. The discomfort does not come from fear of immediate change. It comes from scale. Human experience occupies a small window, while planetary processes extend far beyond it. When those scales overlap in awareness, the mind adjusts its footing, certainty softens, the world feels less fixed, more alive within motion. This shift is subtle. It does not demand reaction, it simply invites reconsideration. Habits of thought shaped by short time frames begin to stretch. The idea of permanence gives way to continuity. The present remains valuable, but it no longer claims exclusivity. Perspective widens through accumulation rather than shock. Evidence builds quietly, connecting layers of understanding. Ice records reveal long patterns. Geological processes show patience. Climate cycles demonstrate repetition without intention. Together, they present a world governed by rhythm rather than stability. This knowledge unsettles because it removes the illusion of finality. It suggests that the current arrangement is neither the beginning nor the end. It exists within an ongoing story that continues regardless of comfort. This does not diminish human experience. It places it within a broader narrative that stretches backward and forward beyond any single era. There is a quiet humility in this placement. It reduces the urge to see the present as exceptional. It encourages attention to continuity rather than dominance. Life becomes something that participates in Earth's systems rather than standing apart from them. The unsettling quality fades as understanding settles. What first feels disorienting begins to feel clarifying. Recognizing temporariness does not drain meaning, it enriches it. Moments gain significance precisely because they are bounded. Stability becomes precious because it is rare. This knowledge does not insist on anxiety, it cultivates awareness. It invites a slower way of seeing, one that respects the planet's long memory and patient motion. The present remains where life unfolds, but it is now held with gentler certainty. Perspective shifts quietly, not toward despair, but toward depth. The world feels less permanent and more connected. What once seemed normal becomes remarkable in its delicacy. In that softened understanding, the unsettling gives way to a calm recognition that to live within a temporary moment is not a loss, but a condition shared with every chapter of Earth's long and unfolding story. Earth does not complete its stories, it moves through them. Climate unfolds as a sequence of states rather than a march toward resolution. Each phase emerges, persists for a time, and then gives way, shaped by forces that never fully stop acting. What exists now is not an endpoint, but a moment suspended within motion. The present climate rests inside a pattern that has not reached its conclusion. Ice remains. Cycles continue. Energy flows adjust gradually, responding to orbital shifts, ocean circulation, and atmospheric balance. These processes do not pause simply because conditions feel calm. They operate patiently, carrying momentum gathered over millions of years. Nothing about the current state suggests finality. Warmth exists alongside enduring ice. Stability coexists with long-term variability. The planet has not resolved its deeper tendencies, nor has it settled into a fixed configuration. Instead, it occupies a position within a cycle that still has distance to travel. This understanding reframes the idea of progress. Climate does not progress toward improvement or decline. It moves through expressions shaped by physics rather than intention. Cold and warmth appear not as opposites in conflict, but as phases that alternate within constraint. Each leaves traces. None erase the others entirely. The ongoing nature of this cycle explains why certainty remains elusive. Records show repetition, not closure. Past climates shifted gradually, sometimes lingering, sometimes transitioning more quickly, but always continuing forward. Even the most stable intervals eventually changed as conditions accumulated beneath the surface. The current chapter follows this same logic. It carries its own character, defined by softness and relative calm, but it does not stand apart from the chapters before it. It inherits their structures and passes them forward. Ice persists, feedbacks remain active, the deeper machinery continues to turn. This perspective alters how the present is held. Instead of being treated as a completed achievement, it becomes a living interval. The climate is not broken, nor is it finished. It is behaving as it always has, adjusting within bounds that shift slowly over time. Nothing being settled does not imply disorder, it implies openness. The system remains responsive. Conditions evolve as influences interact. Stability can persist for long spans without becoming permanent. Change can occur without sudden collapse. The planet expresses continuity through motion rather than stasis. Human experience intersects this process briefly. Societies arise, adapt, and record their surroundings during a narrow slice of the cycle. These records capture texture, not totality. They reflect how the climate feels rather than what it ultimately becomes. The broader movement continues, regardless of observation. Seeing the present as an ongoing chapter softens expectation. It removes the pressure to define the moment as normal or abnormal. Instead, it becomes another expression of Earth's long rhythm, shaped by conditions that existed before and will persist after. This view does not demand urgency or detachment, it invites attentiveness. The climate is not something to be solved, it is something to be understood within context. Each phase carries information about how the system works and how it responds. The unfinished nature of Earth's climate cycle does not diminish the present, it situates it. Warmth, ice, stability, and variability all belong to the same unfolding pattern. The planet remains in motion, not toward an end, but through a sequence without final chapter. The current state is meaningful precisely because it is temporary. It offers conditions that support life in particular ways, while revealing the structures that limit and guide those conditions. The cycle continues quietly, steady and indifferent to resolution. Earth has not finished its climate story because it was never meant to. The narrative exists without conclusion, defined by persistence rather than closure. This chapter is simply where the pages have paused for now, held open by forces still at work, waiting to turn again. Humanity occupies a narrow corridor carved between immense forces. Behind lies deep cold, the long presence of ice that shaped landscapes and climate states over millions of years. Ahead stretches deeper time, a scale so vast that individual lives dissolve into continuity. Between these, human experience unfolds, brief and concentrated, held within conditions that are neither the planet's harshest nor its most common. This position is unusual. For much of Earth's history, conditions were either far warmer or far colder than those known today. Long intervals passed with no permanent ice, while others were dominated by it. The present exists in a balanced space between these extremes, where ice persists but does not dominate daily life, and warmth spreads without fully erasing deeper structure. This balance allows complexity to flourish. Living between extremes shapes perception. The cold that defines the planet's long-term behavior remains mostly distant, locked in polar regions and high elevations. Deeper time remains abstract, revealed only through stone, ice, and record. What fills awareness instead is the immediate, the seasonal, and the familiar. Life unfolds within a comfort zone that feels expansive precisely because it sits between harsher boundaries. This moment is rare not because it is fragile alone, but because it occupies a specific alignment. Ice exists, yet it does not advance relentlessly. Temperatures support agriculture. Coastlines remain broadly recognizable across generations. These conditions have occurred before, but they do not define the planet's norm. They appear, persist for a while, and then change as deeper cycles continue. Human experience narrows within this window. Attention focuses on years and decades, on patterns that repeat reliably enough to be trusted. The scale of concern shrinks to what can be remembered, planned for, and inherited. In doing so, awareness gently detaches from the broader forces that make such predictability possible. Between extremes, stability feels natural. The absence of constant threat encourages the idea that the environment is settled. Variation appears as anomaly rather than expression. The deeper context, where ice advances and retreats and continents reshape climates, fades into background knowledge rather than lived reality. This narrowing is not ignorance, it is adaptation. Life responds to the scale that matters most for survival and meaning. Deep cold and deep time remain too large and too slow to engage directly. They form the outer walls of experience without entering daily thought. Yet those walls define the space within which life unfolds. The calm that supports cities and cultures exists because the planet has not tipped fully toward either extreme. The ice holds its place without overrunning the surface. Time moves forward without abrupt rearrangement. Humanity benefits from this balance without sensing its rarity. Living between extremes also carries humility. It reveals that human history occupies only a thin layer within Earth's story. Achievements rise and fall without altering the planet's deeper rhythm. The corridor of comfort does not exist because of intention or design. It exists because conditions aligned for a while. This understanding does not diminish human experience. It gives it context. Meaning arises not from permanence, but from participation. Life unfolds within a moment shaped by forces far larger than itself, borrowing stability from a planet that has never promised it. The narrowness of experience explains why shifts feel surprising. When conditions begin to drift, the change stands out sharply against expectation. The deeper system has always moved, but attention rarely follows it. Living between extremes trains perception to notice comfort more readily than context. Between deep, cold, and deeper time, humanity finds space to exist, reflect, and build. This space is neither infinite nor guaranteed. It is a passage rather than a destination. The rarity of the moment lies not in its beauty alone, but in its position within Earth's long motion. To live between extremes is to inhabit a pause in intensity, a chapter where forces balance just enough to allow awareness. The experience feels complete because it is all that is felt. Beyond it, the planet continues its quiet movement, carrying this narrow interval forward as one more expression of a story far larger than any single moment. The realization settles slowly, without drama. The world is not broken. The systems that shape climate have not failed, nor have they veered off course. They are behaving as they always have, moving through states guided by physics, feedbacks, and time. What feels unsettling is not malfunction, but recognition. Climate is often spoken about as if it should reach an endpoint, a stable configuration where conditions remain fixed. Yet Earth has never offered permanence. It offers continuity instead, a steady unfolding shaped by forces that do not aim for comfort or completion. The present state is not evidence of disorder, it is evidence of motion. The climate is not finished because it was never meant to be. Ice advances, retreats, and persists. Warmth spreads, stabilizes, and softens. These expressions rise and fall within a framework that remains active across millions of years. Change does not signal failure. It signals that the system is alive and responsive. Understanding this reframes concern into context. The planet does not need repair. It does not require correction to return to an imagined normal. What it does is adjust, slowly and patiently, according to conditions that extend far beyond any single era. The discomfort arises when human expectation collides with geological reality. Living inside a long ice age does not mean living in constant cold. It means living within a climate state defined by permanent ice, long rhythms, and recurring cycles. These features operate quietly beneath surface warmth, shaping winds, oceans, and energy balance without demanding attention. Their presence does not announce itself, it simply endures. This quiet endurance explains why the truth feels counterintuitive. Daily life unfolds in green landscapes and temperate seasons. Snow and ice appear distant, confined to maps and images rather than experience. The idea of an ice age feels incompatible with comfort, yet comfort exists within structure, not in opposition to it. The ice age persists as context rather than condition. It frames what is possible without dictating what is felt. Warm intervals bloom within it. Civilizations rise within it. Stability emerges briefly within it. None of these contradict its existence. They are expressions permitted by its boundaries. Recognizing this removes the pressure to define the present as exceptional or final. The climate does not owe humanity resolution. It moves according to forces that predate human awareness and will continue beyond it. This does not diminish the importance of the present. It places it within a longer story. The unease comes from scale. Human experience favors closure, solutions, and endings. Geological time offers none of these. It offers sequence. One state gives way to another without announcement. Calm does not signal completion. Change does not signal collapse. The system simply continues. There is a quiet humility in accepting this. It softens the instinct to see the world as either saved or lost. Instead, it appears as a dynamic place, neither stable nor unstable, but perpetually adjusting. Life exists within these adjustments, borrowing conditions when they align and adapting when they drift. The realization becomes uncomfortable because it denies simple narratives. The world is not broken, so it does not need to be returned to an earlier version. The climate is not finished, so it does not promise permanence. And humanity lives inside a long ice age, even when the air feels warm and the ground feels firm. This understanding does not lead to despair, it leads to clarity. The present becomes valuable not because it will last, but because it exists now. The calm that supports life is revealed as something to understand rather than assume. In that clarity, the story completes itself quietly, not with certainty, not with resolution, but with perspective. Earth continues its long motion. Ice remains, cycles turn, and life unfolds within a moment that feels ordinary only because it is being lived from the inside.